Tired of manually switching scenes, muting mics, and clicking record every time you stream? Today, you'll learn how to fully automate OBS Studio using Python, controlling your broadcasting workflow directly from code. Welcome to this hands-on Python automation session. OBS Studio is the powerhouse of live streaming and recording, but interacting with its interface manually can slow you down during a fast-paced show. Fortunately, OBS features a powerful WebSocket server that allows external applications to communicate with it. In this lesson, we are going to write a pure Python script that connects to OBS, inspects current scenes, and triggers actions without a single manual click. By the end, you'll understand how to build your own custom streaming deck entirely in code. Before writing code, we need to understand how Python talks to OBS Studio. OBS uses a WebSocket protocol, which means it runs a local server listening for incoming JSON messages over a network socket. Our Python script acts as a client that opens a TCP connection to this server, sends structured requests like switching scenes or starting recording, and receives responses back. It is a lightweight, asynchronous-friendly architecture that runs locally on your machine, requiring zero third-party heavy dependencies if we implement a basic client, or leveraging standard socket communication. Let's start by establishing a raw network connection to our local OBS WebSocket server using Python's built-in socket library. In this snippet, we define a simple function that creates a TCP socket, points it to localhost on the standard OBS port 4455, and prints out the connection status. This forms the foundation of our entire automation pipeline. Connecting to the port is only the first step. The OBS WebSocket protocol requires a specific authentication handshake when a client connects. Version 5 of the protocol sends a greeting message containing authentication details if a password is enabled. Our script must read this initial JSON greeting, check if authentication is required, and respond with a properly formatted identification payload containing our hashed password if necessary. Understanding this handshake prevents connection drops and unauthorized error responses. To handle the handshake without crashing, we can write a helper function that parses incoming JSON strings and constructs the correct outgoing response dictionary. Here, we use Python's built-in JSON library to serialize and deserialize messages. This snippet demonstrates how we prepare our identification payload before sending it over our active socket connection. Once the handshake is complete, OBS expects request packets formatted with specific operation codes. Request messages use opcode 6. Every single request we send to OBS needs a unique request identifier, usually a string or number, so that when OBS replies asynchronously, our script can match the response back to the original command. We will design a request builder pattern in Python to automate the generation of these unique IDs every time we want to trigger a scene change or check status. Let's write a clean Python class that generates properly formatted request structures for OBS commands. This class keeps track of an internal counter to ensure every request ID is unique, and wraps our target request type and input data into the exact dictionary schema that the OBS WebSocket server expects. One of the most common automation tasks in live production is switching scenes dynamically based on external triggers, such as timer events, chat commands, or file updates. By sending a set current program scene request through our WebSocket client, we can instantly tell OBS to switch our active broadcast view. This removes the need for hardware stream decks and lets software logic drive your visual layout completely. Here is how we construct the specific request data payload required to change scenes in OBS. We combine our request builder class with the target scene name parameter. When sent over an active connection, OBS immediately switches the live canvas to the requested scene. Automation scripts must be robust against unexpected failures, such as OBS closing midstream or network interruptions. Implementing try-except blocks, proper socket timeouts, and parsing error codes returned by the WebSocket server ensures your automation workflow won't crash your entire production setup. Always validate response status flags before assuming your command executed successfully. Let's write a short script that processes a mock JSON response from OBS, checking whether the request was successful or if an error occurred. This pattern allows your Python script to react intelligently to the state of OBS Studio in real time. Congratulations! You now understand how Python can interface directly with OBS Studio using WebSockets, JSON payloads, and socket connections. You've built the foundational blocks for request generation, handshaking, and response validation. From here, you can expand this script to monitor stream health, automatically start recordings on a schedule, or integrate with APIs. Happy automating, and enjoy streamlining your production workflow.